accepted.
Welcome back. I think this is one of the last talks of today. Do you hear me okay? Thank you. I love when things just work. Still amazed to this day. Today we will be talking about a bit of a Docker, a bit of Nix, Nix and Docker, everything in between, around, and it's going to be fun. I'm Rock. I'm a software engineer at Flux. I've been using Nix for let me think. I think it was, more than 10 years now. So for those who know Nix, this is quite, like Nix is not a new tool that was just invented yesterday, but it's still quite a lot. And I had a chance to teach many newcomers to Nix why to use it, how to use it. I failed miserably many times. Hope I learned by now. But I had also many successful stories. And I've taught Nix in small organizations, really small, like maybe just 3 developers, and also big ones, like 500 and more. Adoption and how this happens, it's quite different. At the same time, I also use Docker. I use it today. I used it before Docker was Docker. The containers were around for quite some time. I still remember the days when we had to fight with the LXC in the command line. I use Docker today, and I use Nix today. And what happens a lot of times is that you have these very passionate engineers on either side, which will not consider the other tool to begin with. On one side, we have Docker, and as a Docker developer or a Docker developer that uses Docker, and you invest so much effort and time in your scripts and how you manage your workflows, your CI, maybe then pushing to production, you really don't want to hear that you're doing it wrong. I understand that. And then on the other side, you have Nix people, I would even say more passionate, louder, which are telling from the high tower, it was like, hey, everybody's doing things wrong. There is some sort of, and it's true, I witnessed it myself, you kind of reach this, like we call it a Nix God complex. Not a good place to be, because you kind of lose the side. But it's, while others are struggling with the problems, you don't have them. And it's frustrating telling people that, hey, just use my tools, and you won't have these problems. So it's really frustrating. That's why people with this God complex are loud. But they do, and I did as well, forget one crucial thing is that we all started learning Nix, and that learning Nix was really hard. And that's why it's really hard for somebody that does not know Nix to learn it. So you have on one side very emotional people, on the other side very emotional, and usually it's just shouting all across. And I want to break this, and I think to be in the last few years, what happened was that I started using both, and I think I've never been happier. So when I say use Nix, at the same time, I also advise people to use Docker, and vice versa. If you want to really have a better Docker flow, use it with Nix. And if you want to introduce Nix to as many developers and engineers as you want, like, use Docker to get you there. But I would like to maybe start differently. There is a lot of tutorials online that will tell you how to use Nix and Docker. They have all ups and downs, but there is very few of these tutorials give you the reasons why you should do this. And I think that more than how to do it is important why. And I hope today's talk is going to be one of those breadcrumbs that I will leave behind, that when your time allows you, when your kids leave you, that you can actually do the real work, that you will come back to the talk and maybe get some hints how to get you started. Small, easy steps. So that's my idea. But today, kind of starting with the why, because when you first say, like, hey, you should use some new tool, it was like, why even use Nix? Well, first, what is Nix, right? So once you get to that point, you're like, why would I even use it? My workflow of development is perfect as it is. And then, of course, then you're starting doubting yourself, and you're saying, like, okay, but is Docker not enough? And this is what I'd like to, like, especially in the beginning, I would like to address. But before we go forward, by the show of hands, who here uses Docker? Just like, okay, 100%, 99, I would say. So who in the audience heard about Nix? Okay, it's 10%. Okay, let's say 10%. I'm bad at counting, plus the light is in my face. Who is using Nix? So this is different. Yeah, it goes steep down, so it's another reduction of, like, it's, I would say, 5%. So that's the normal picture of how widespread Nix is. So if you don't know it, I think it's worthwhile to give you like a short or one slide, not to go too deep, but enough that we can go for the next 20 minutes to kind of guide you and give you these breadcrumbs to be able to dig yourself. So, Nix. If I have to tell you what Nix is, it could take either from 5 minutes to an hour, or I can talk about it the whole day. It's a really a Swiss Army knife of tools that you can do. Now, in essence, it's a command line tool that comes with its own language that you execute, and it builds stuff. So you build software, and that's its purpose. It's if you statically compile it, it's 20 megabytes, roughly, of binary that you execute, and software comes on the other end, or comes on your computer. You can compare this with, you have I don't know, Python, Ruby. It's a CLI tool that compiles or interprets your code, and it produces something, right? So Nix, very similar, except Python and all these are general purpose languages, while Nix is built, and the language that comes with, it's built for package management. So Nix, a package manager. Some also use it as a build tool. Kind of the line where does the build tool starts and where the package manager begins, it's a bit shady in some cases. On the other side, with that, once you have this tool, you want to build something. And to build something, you need sort of build recipes. And these build recipes are collected in one repository. We call it Nix packages, NIX-PKGS. And this is the repository, Git repository on GitHub, where all the recipes of software out there are located. So when you do Nix install something, you say, it goes to the Nix packages repository, looks at the recipe, can I build it? Is there a binary for it? Replaces the output with the binary. If there is not, it will build it from source. All good so far, right? Nothing really new here. On the end, I don't want to confuse you. We're not going to talk about it, but I do want you to know this information when you go out, that when you combine Nix ideas and Nix packages, you can also create a NixOS distribution. So it's a Linux distribution with all the properties that are available for Nix package managers are also available then at the NixOS the Linux distribution level. Now, you don't have to use NixOS, right? You can, on your existing distribution or your macOS, you can already use Nix today without the OS part, right? So just the package manager. You can consider it as a replacement or actually not a replacement, as an addition to Homebrew. And that's actually where Nix really shines. It works alongside any other package manager. I don't want to go in details because we only have so much time. How does that work? I'll gladly talk about it afterwards. But trust me if I say they do. Now, what is really interesting is that this is a screenshot, and it's horrible, but because it's all in small letters. But what it shows is that here on the right side, those dots, it's correlation between the size of a repository and the freshness of packages in that repository. And you have from Ubuntu, Debian, you name it, it's there. It's Arch, user repositories, and all of that. On the top, if you have a place on the top right part, is it really right? Yes, it is. Have to double check. That means you have the most amount of packages, and they are the freshest. And this is all across our stable releases from half a year ago to our current releases. So if you come to Nix ecosystem, this is talking about packages in the Nix packages repository that I was talking about. It has over close to 90,000, or it's maybe even over by now. And it's growing. Now, how can we do this? We automate the shit out of it. If I use one swear word, it's still considered PG-13, so one, done. So we automate the heck out of the whole thing because of the concept that Nix brings you. Now, what you need to take out of this is that Nix is actually really actively developed repository. It's listed as every year for the last, I think, 5 years as one of the most active repositories out there in terms of contributions, right? And what happens in that, right? This year, I think this is from last year. This is from Octoverse, I think it's called, so GitHub's sort of status reports. It's like we are just behind Next.js. Although, we package, basically inside the Nix packages, we package everything, from Linux kernels to Linux modules to Node.js, Python repositories, Python packages, Haskell packages, you name it. Which, if you have to ask me what makes Nix stand out, or the whole Nix ecosystem stand out, is actually Nix packages. It's really invaluable that anywhere you go, you can take any of these packages with you, because it does not conflict with your existing package manager, let's say apt-get on your system, or your Homebrew on your macOS. So if you have to take away something, there is a collection from today's talk. There is a collection of packages that you can get, will work on any of your machines alongside, and you can just tap into that power. So this is a short, so we have a kind of recap. We have Nix, we have the CLI tool and the language. We have Nix packages, collects a huge, enormous collection with lots of contributions, and we have NixOS, which it's a talk probably, or talks on their own. So now that we know what Nix is, let's maybe go back and start answering why. And I think I cannot speak for everybody else, but I can speak for myself. I use Docker. I had my perfect Docker workflow. I developed with Docker, as we all do. So actually, even when you're developing, you either have to choose whether you will either you will have a local development environment, which means a big README. There are instructions how to install all your system dependencies, or you are in a Docker environment, which is let's say, which you don't have tools that you're sort of familiar with. Like your editor is not there, your shell is not configured to your liking, so you have to choose. Now, yes, I wrote many tools that work around this. It's not fun. Just assure that on one project you can use many of Docker images, and then you have to switch between them, because I cannot have there is not an easy way that I can have from a command line at least, that I can have a Docker environment with Python and I don't know, Node.js. It's just hard. You need to sort of write your Docker file and then you build it and so on, which it's nice. But there is a Python Docker file, and there is a Node.js file. It's like, merge them, please. It does not work like that, sadly. So development, yeah. I personally dislike using Docker for development these days. CI. It brings another like using Docker in the CI setup. It brings additional level of complexity. Now, if I know we all know, your local development should be as close as possible to your test in CI environment, and your production should be, all should be close. Reality, it's not like that. Your configuration for CI leaks abstractions. You move fast, you switch branches, and then CI doesn't work. It happens to me a ton of time that I commit a code, it works locally, awesome. I push to the CI, and then CI is just like yelling at me that something is broken. And I test it works here, it doesn't work there. Even with Docker. And it's just not the nicest solution. Now, there are pieces of Docker which I still use, but I found a better way. Let's put it this way. I'll show you later. Production. Actually, Docker in production is pretty nice if it fits in your deployment story. If you need to deploy on a really low bare metal, embedded systems, you will not use Docker. But then if your project fits into Kubernetes, awesome, you're good to go. Like, that's a perfect scenario. So generally, like, the whole software development, or at least this part of the software development lifecycle, could be improved. And here but I want it also to be as easy as Docker, right? I really like that I can just give somebody a Docker file and they understand it with the basic knowledge of a bash. Like, we should not compromise on that as well. Especially because, I don't know, maybe I'm just gray a bit, and with years I started losing patience to teach from ground up. I think things just need to be created with enough intuitivity that people can just pick them up naturally. And it's possible. Nice example is Docker. So what I want, it's very simple. I want my environments, in either cases, to just, bad word, work. Now, using Nix, these problems, part of them at least, that I care, go away. But of course, they go away for a price. So if you switch to a Nix solution, they go away. You pay the price. What's that price? Nix is not the easiest one to learn. So it's a trade-off, right? I mean, we software engineers, we always deal with trade-offs. That's yet another one. So there you go. You won't escape it to the end of your career, but it's a trade-off. So it has a steep learning curve. So how can we sort of soften this learning curve? Are there some shortcuts? Basically, I want to have the cake and eat it at the same time, right? Now, without talking, so these are the reasons why I think you should consider using Nix in some small cases. Try it, take it back. Doesn't work, come back to it maybe when you think it will work. It's being heavily developed. There are many startups around now that do this. There are many projects that try to simplify it, and it's just a matter of time when this is going to be increasingly easy. Today, what we can do today, I'm showing you 3 examples. So first, am I just on the right machine? Yeah, okay. What I just did there, because I have Nix installed, you can actually just run any package, so it will download it and run it, so you don't need to install it. That's why I don't have stuff installed on my laptops anymore, because I can just, Nix run and you go. So, but there are 3 examples. First, and they are sort of, you're a bit graduating with each one, right? There it's like a level of difficulty increases, and based on how much time you have, how much frustrated you are with your current workflow, or just how much fun you want to have. So first example, Nix in a Docker file. Well, if you use apt-get, a package manager in a Docker file, well, you could do as well in like you could use Nix in a Docker file already. So here's an example. So this is a folder. There's only Docker file inside. So what do we actually use here? Let's go to the top. So we use Nix. We do a multi-stage build, Docker build. So we will use Nix part, the first part, as a builder, and then copy over all the environment that we want to have in our result. So we use the native Nix Docker. We kind of copy whatever it's in our current directory. So if there are some projects, then this is actually what you need to learn. And kind of going from the top, you use the Nix command. There are some experimental features there. Don't be afraid, they will soon be turned off, and they will be, because they are already, everybody's using them in production, so they're almost ready to be stabilized. There is an option filter syscalls. This is just local, so that you can build, Intel packages on a Silicon thing. It's a macOS thing, so. Then you have the real command, so if this would go away, it will be Nix profile install, and then you list which packages. And then you also defined where to put this profile. Now, which packages? So I said, you can see in front you have these Nix packages and then hash and then a package name. So which packages are available? So this is search.nixos.org. And yeah, they are more than 80,000 packages. Now, this always goes wrong, but anybody idea that a package that you could not have on your distribution, but so you had to build it? An example? Just to search for it? Node.js. What's the new Node.js? How is it called? No idea? Me neither. Awesome. So Node.js. So you have few versions of Node.js. So also you have a slim version if you do some fancy stuff. Yeah, bunch of stuff. So I don't know. I heard before there is Scala. You have few versions of Scala. The next version of Scala is Dotty, right? So if you need to experiment, Dotty, right? It's a Scala 3.0. If you need to try it, actually, while we're at it, Nix run Nix packages, Dotty, like it's there, right? It didn't download it because I was not sure about the Wi-Fi, so I pre-downloaded, but otherwise it would go online. We'll see later when things go online. So really what you need to learn is how to do multi-tier build, Docker file, learn this command. What happens afterwards? Maybe that's also important. So it basically takes everything that you installed in that /temp/build/result, and it will take those packages and their dependencies. This is in terms of, in Nix language, it's called, in the Nix lingua, it's called full closure of a project, right? So packages and their dependencies down to GCC if needed, right? And it will copy them into this, how do we call it here? Nix store closure. And this means that in the next phase, you have this from scratch. You set a work there, you copy from this builder, and send some environment variable, CMD. That's it. I think apart from that big Nix command where you literally need to specify which languages you want, it's nothing special, right? This way you can, and those are binaries that you will get, so you can really combine. Yes. Any questions so far, regarding this? It's pretty straightforward, right? This means if you know Dockerfile, you can use this to build your own development environments or with certain tools inside. Pretty handy, without knowing any Nix, the language, I mean. Now, how to sort of build it? How was the Docker build? The Wi-Fi work? Yeah, perfect. Thank you. You saved me. Yeah, please. So the question, just to repeat it, why is this better than apt-get? I'm going to answer later a bit, like on the third. So once I build it, I will actually show you why, but then it has to do with composability, right? You also don't need to, so there are a few things. You will see the composability, how it shows later, but the first part is you don't need this base image, right? You saw it that I started from scratch, and then I copied everything that I need. So your images should be as minimal as you want them to be, right? Depends who you ask, right? So I know some people will say this is not an advantage, but yes, my opinion is also I would like to have a minimal set of tools in my environment, so the least things I have, the least of the things can go wrong. And that's, for me, the most important. Especially, it's not the first day when I create the Docker file, but it's actually the day number 400, 500. So when few people already left and new people joined, and that knowledge, why was certain things added, it gets lost. And if you have everything declaratively, sort of, the more declarative you can be, the better. We'll see this example. So, then I'm a bit too big for these podium images, right? So there we go, 385 megabytes, it's there. If I run it, so instead of running it, I'm actually gonna, I'm gonna inspect it. I'm just using, what is this, dive to inspect the Docker image, so we can see the layers and what's inside. It's gonna take a bit. I hope the resolution will work, but you will see there are 3 layers. If I go now, I went to the last layer, and everything inside the bin directory, it's sort of symlinked to the /nix store. That's how Nix works, and we can talk about why is that. Now, if I go, okay. Now everything, so all of the files are basically symlinks to the /nix store. Now, if you look at the store, and I'll do something very, okay, so can I, you cannot really see, but how can I remove, can I move to the right? No, I can't. But there is you see some gibberish, some hash. On the end of it is a name and a version of that package. So all those packages actually live side by side. So if you have 2 versions of Python, they won't conflict because the hash will be different. How the hash works, please talk to me afterwards, I'll happily explain it. The purpose of this is, what you just get is full dependencies of your sort of project. And you can actually call this, if you squint a bit, or you convert it as an SBOM, right? So these are the versions and files that, that were used to build your project. Now, coming to composability, very short there. So is this better what we just did? Yeah, I think it is better than apt-get. You get, for a few reasons. The one which is like the crown which I put on Nix packages is like you get access to more recent and much more software. Just for that, I would kind of consider using it. Now, going further, second example. Now, be warned, a bit of Nix. But there is still one thing that it's kind of frustrating me there is when I do Nix profile install, it takes the latest versions of the Nix packages, and whatever is the latest there, it will install it, which is, it's exactly how Docker files today work, but I think with Nix we can do better. So I want to lock, and when you are ready, you will be able to bump those. So what we do, the only change we did, everything else stayed the same, is that instead of profile install, we are now using a build subcommand, and everything the same. Now this build requires this flake Nix file and flake lock file. Lock is where those dependencies are, which revision of Nix packages repository are you using. So you will, if you run it today or tomorrow, the Docker build, you're going to use the same version all the time of Nix packages, right? So if you can squint a bit, I'm saying here are the inputs in this line, Nix packages, take it from some branch, which is the latest. And then here I set all the packages, and then create this built environment. So when I build it, that Nix built inside the Docker file is going to do the same thing as that command. It's much more declarative, plus you locked your dependencies, right? All of it, completely. So if you do, what happens very often with Docker build is like you do it today, and it works Docker build, you do it tomorrow, might not work, right? Because we all put apt-get update because of the convenience there. Now with this, when you lock it, yes, you need to maintain it, but that was a choice. There is a Nix flake update which updates these lock files for you. And as a bonus, below, you also get these dev shells, development shells, which, I want to use the same development environments as in a Docker, the same binaries. That should be easy as doing Nix develop. And that will use the same binary, the same list of packages. Put me here. Okay, I think I just. Which packages do we have? Poetry. So definitely I don't have poetry. Okay, Nix develop. Develop. It drops me into bash by default, but let's fix this by adding sort of the zshell command, because I use zshell and then I have all my nice stuff. And let's see, poetry, which poetry? There we go, it's ready. So I can do local development, and then the same binary, right, if the platform, of course, matches, is going to be used inside the Docker image. Right, so you can you remember when I said I'd like to use the same tools inside the Docker image as outside? That's the thing, right? Plus I have it locked, so I know I have the ability, if I want, to actually bump my dependencies. The last example, so same thing, the Docker file is there. We are actually replacing the whole Docker file with Nix. And I'll tell you why. So if I first open you Docker JSON. It's actually, this is just an example file, but I want to kind of put the message. If I give you this JSON file, will you understand what it does? You give it a name to a Docker image, you give it a tag, from image, so what's, the same thing as from scratch, because created, what's the timestamp, contents, those environment, the configuration, it's sort of similar from the specification if you know it from Docker, so the JSON specification. So, and could we have this in JSON file? Yes. There is even better, you can have it in a Nix file. Reasons we can discuss later, I'm short on time, but there is basically, there is a function called build layered image. The syntax is a bit different, but very similar to what I just showed you as a JSON file. You list packages, because it's a language you can concatenate to lists, awesome. You can share this code. You can still have Nix develop. Now what happens, and I want to show you this, is instead of using Docker build, you actually don't need Docker to build a Docker image anymore. You can just do Nix build. Why is this cool? Of course, I built it already. So let's load this image. It says build layered image, the function, right? So what it does, because we have this knowledge of our packages and their dependencies, we can actually, without thinking, create layers to have them the most efficiently stored. Because order of layers in Docker image is really not, from specification point of view, is really not ordered. In the end, they just get smushed together. So in this, we just created an image, which whenever you change your project, only the last layer will change, so the least amount of update code. So when you do the next, or where your production does the Docker pull, really the last layer will only be updated and then smooshed together. So you gain a lot there of reusability, which, if it's a small project, small startup, doesn't make sense. If it's a huge company, 500 developers, this really saves a lot of money. So we load it, I don't know, Docker images. So this was the my environment 3. How do we say Docker run? Docker run remove IT my environment. Oh, I know what I did wrong. This is the problem because inside are of a different architecture, right? Because we built it for the wrong architecture. We need to build it for Linux 64. We have a remote builder which did this work for us. Now Docker, say load. We need to reload the image, right, that we just built, although it didn't look like, so it's loading again the layers. Let's go Docker run. There we go, and you're inside the bash. So it's really hard to explain. I'm already over time, so I'd like to, they are benefits. I showed you maybe 3% of what Nix can do. And the core Nix is really a simple idea, but then when you take it to these multiple levels, it just blows your mind once you see it. Now, should you always use it? No. Should you use it in combination with Docker? Definitely yes, I think. It saves you a lot of times, give you access to certain things that you did not have before, or they were a bit harder. Now they are more convenient. Plus it opens, you can do local development if you need to. Building Docker images becomes really easy. To finalize, we have Nix. Just to recap on short, we have Nix, we have Docker. Use them together, not against each other. And you're going to be a better developer if you use better tools. I think using Nix and Docker together is the way to go. Of course, I would like a tool that it's as easy as Docker and powerful as Nix, so that you get. This is where we come as a startup. We are actually taking, with all our expertise that we have in the last 10 years, we are building something that will be as easy as Docker, As easy as writing a Docker file and then still gives you most of the powers of Nix. So hopefully at my next talk, I'll be able to show you how these things work. If you want, I can also give you a sneak preview, but that's on the side, not in front of the cameras. Thank you. Questions? Probably it's not the time, but I'll be here. I'll be happy to show everybody around. Thank you.